Hi friends, I am Gandhimathi, Assistant Professor of GVN College in the Department of Computer Science. Now we have to discuss about data structure. So data structure, first you have to think friends, why we are studying data structures. In our life, data is played in major role. When we are using mobile phone or computer or maintaining records and gathering information from the various sources. If you are using mobile to access Facebook, Twitter, WhatsApp and so many applications in day-to-day life, data we have downloaded or uploaded in the form of text or video and audio. So in our life, very huge amount of data to be processed. So one of the biggest problem in our life, how to store the data and how to process the data and how to gain the knowledge from that data and how to keep the data in secret ways. So that's we have to study the data structure, what you have to store the data in the form of data structure. So in that way we are studying data structure. Our support of computer science is all about storing and computing from a given data. So studying data structure help us you deal with the different ways of arranging, processing and storing data. So all the codes are made for real-time purpose. So data structure allow to user to keep the records or handle the records in various ways. So now we discuss about data in the topic of stack. So stack is a very common data structure used in programs which has a lot of potential and gathering information to store the data. Stack holds an items, usually all of these same data types. It follows the concept of stack is LIFO, last in first out. So stack is a linear list of items which all additions and deletions are restricted. One end is called top. The top is a pointer. It will be storing as well as deleting an item from that stack. Friends, you have to imagine the container. The container, we have to store the chocolates to the, we have to store the items into that container. So you have to think friends, first container is a closed element of stack. Container is a closed element of stack. We have to store the data in that container in the top pointer. So just you have to imagine what is stack. Stack is a linear or homogeneous item of stack. So it processes the element of last in first out. So one of the pointer is called top pointer. So the top pointer is used to insert a data or deleted a data from that stack. Okay friends? Okay, so many applications we have used in stack. So real life examples, we have to arranging a books. So arranging the books is one by one is called as a stack. So another real life example is arranging of coins. So the coin arranging is called as a stack. So what are the methods to arrange the coins? You have to insert the item in the top of the position in that stack. Top of the position in that stack. The top pointer we have used to insert the coins. And the top pointer is used to insert the arranging of books. So as well as we have to remove that the book, we have using the top pointer. Okay friends. So as technical related applications we have used page visited history in a web browser. You have to think friends, you have to browsing the such items, you have to store the what are the various browsing items in your memory, it will be stored in that web browser history. So it is called as one of the method of stack. Stack is homogeneous environment of elements or same type of elements we have stored in the stack. Okay, it means that last thing we have added in the first thing. Last thing we have added in the first thing. You have to insert the data. Okay, so stack is a sequence of items. Stack is a sequence of items to access the only one end of the data. So stack operations. The stack operations are push, pop, is empty, is full. Okay, so you have to just imagine the stack is a closed container. The bottom of the stack is sealed. Okay, so next, stack may have store the capacity. So the capacity is the maximum element, is the maximum limitations. Maximum limitations to store the data. Okay, so first operation is called push. Push means inserting an item in the stack. Okay, so we have to insert the item into the stack. We have using the push operations. Pop means removing the item. Push means inserting the items into the stack. Pop means removing the items from that stack. Okay, so next, is empty and is full is reports whether the stack is empty or not. It will be report whether the stack is empty or not. Is full reports whether the stack is full or not. It will be reaching the exits of capacity or maximum limitations of the stack. Is called as a stack full. Okay, so now we have two examples with stack operations. Here we start the examples of push operations for that stack. Okay, so the stack, the maximum limit of the stack is, that is capacity of the stack is 6. So we have arranging the 6 locations in that stack. Okay, first you have to push with the element of A in the stack. Yes. Okay, so you have to push the element in the stack. The A will be inserted in the top pointer. Okay, so after that insertion, top pointer will be incremented by 1. So the second element will be pushed into the stack for the element of B in the stack. Yes. So the second element will be inserted in the second position or first position of the stack. So automatically top pointer will be incremented by 2. So after that, C, D, E, F and the 4 elements are inserted in the consecutive methods. We have to store in the stack. Now the stack top pointer is 6. Now the stack top pointer is 6. So it will be reaching the maximum limitations or capacity of the stack. Now you have to push the additional element G into that stack. Okay, the stack reports now the stack is overflow because the top pointer is 6. It will be reaches the maximum element of the stack. So we cannot insert into the element in the stack. Okay friends. So the next operation is pop operation. So the pop operation means deleting an item from that stack. Deleting an item from that stack. So pop, once you have to call the deleted item, F will be deleted from that stack. Automatically top will be decremented by 1. Okay. So the stack is again reinforced by A, B, C, D, E. The last pointer, it will be written from the top. So now the top is equal to 5 because you have to delete it from one item in that stack. So second, we have to call the pop-up stack. Again the last element, that is last in first out. Okay, A, B, C, D, E will be written out. So E will be written out. Now the top pointer decremented by 4. So first one 6, the maximum capacity of the stack. Next the F will be deleted from that stack. The top pointer decremented by 1. So now the array or stack is considered as a top pointer is 5. So next you have to call the again pop operation. So next topmost position item D will be deleted from that item. So automatically top decremented by 1. It will be treated as 4. Okay. So again pop of stack the topmost pointer A, B, C. D will be written out. Okay. So automatically top pointer decremented by 3. Okay. So after that again 3 times pop will be called. Again 3 times pop will be called. So now the stack is written all the elements from that stack. Okay. So now the top pointer is equal to 0. Now the top pointer is equal to 0. So all the items are deleted from that stack. Okay. So again we have to call pop of stack, that is deleting from that item in that stack. The stack reports the stack is empty because all the items in that stack is deleted from that stack. So we cannot pop in that stack. We cannot pop or deleting item from that stack. Okay friends. So next important operation in the data structure is called queue. Next important data structure concept is called queue. So queue is a data structure whose element can be added in the last element and taken from the first element. Okay, it is called FIFO method. It is called FIFO method. FIFO means first in, first out. FIFO means first in, first out. Okay, so queue is a collection of homogeneous or the same type of data will be stored in that queue. So stack and queues are the linear data structure. A new element is added at the end called rear pointer. A new element is called added in that queue is called as rear pointer, and existing element deleted from that queue is called, another end is called front pointer in that queue. Okay, rear is added element in that queue. So front is deleted item in that queue. Okay, so this mechanism is also called as a last in first out method. The last in first out is in the stack. Queue is a first in first out method. So queue operations. So placing an item in a queue is called insertion or NQ, which is done at the end of the queue called rear pointer. Removing an item from the queue is called deletion or DQ, which is done at the other end is called queue. Other end is in the queue is called front pointer. Queue is full abdina, rear is equal to maximum size of queue. Queue is empty, front and rear is equal to 0. So next you have to discuss the queue operations. So first operation is insertion or NQ. Second operation deletion or DQ. So next queue full, queue empty. Queue full, queue empty. Okay. So NQ or insertion means placing an item in a queue is called insertion or NQ, which is done at the end of the queue is called rear pointer. Okay, removing an item from the queue is called deletion or DQ. Okay, so which is done at the end of the queue is called front pointer. So now queue is full, it will be reports the rear is reaching the maximum size of the queue. So if it is queue is empty, it will be reports the front and rear pointer, it means that 0. So now the queue is empty. Okay, now we have to discuss the applications of queue. So real life applications, waiting in a line. Waiting in a line. Waiting in a line, how it will be? The form of queue. So in the form of queue, front and rear pointer, front and rear pointer,
it will be inserted or deleted. So one of the person will come to insert in the queue. Okay, so we have using the real pointer. So it will be placed in the first place of the queue. Okay, next another person will come. It will be insert into the queue. Okay, the real pointer automatically incremented by 1. For that, the second person will be inserted. Okay, so after that, you have to 5 or 10 members will be inserted in that queue. Okay, now the front in the line of the end, rear is the front of the queue. Okay, rear is the front of the queue, front in the line of the end. Okay, so next you have to discuss the applications related to computer science. One is the round robin scheduling algorithm. Next one is the job scheduling algorithm. It will be used in a first in first out method. So first you have to discuss the NQ operation. So now we have to discuss the NQ operation in that queue. Queue can be added. Queue can be added, an item is in that queue. So when it is not full, if NQ is empty, then front and rear pointer is added by 1. If that queue is empty, the front and rear pointer incremented are added by 1. For that, rear is added by 1. How to NQ that or adding the item in that queue? So first item will be inserted in that queue, 3 will be added. So queue element which was referenced by the rear pointer. Okay, so it is filled by new data. Okay, now we have to call the second insertion. For that NQ operation is called front and rear pointer, and Q will be inserted in the next item is 5. In that Q, the rear pointer automatically incremented by 1. It is called true. So the third item will be inserted or NQ. So you have to pass the front and rear. Q value is 8. Now 8 will be inserted the NQ in that Q. Now the rear pointer automatically incremented by 1. It is called 3. Now you have to NQ or inserting a fourth item in that Q. So you have to pass the front and rear pointer Q. The last element in that Q is 7. Okay, so 7 will be inserted. Now the rear pointer automatically incremented by 4. So you have to 4 item will be NQ'd or inserted in that Q. So this operation is called as a NQ. Okay. Now the second operation is DQ. First you have to NQ the element in the Q. Okay, so DQ means deleting an item from that stack. Okay, after the first element is taken from that queue, the second element in the queue will be shifted and first element will be so on. So subtract the rear pointer with 1 in the DQ operations. How to imagine a queue is already previous NQ operations 3, 5, 8, 7 and 4 items will be inserted in that queue. Now the rear pointer pointing that to all places. Now the rear pointer pointing to the all places. So front will be in the front of the queue. Okay. So first you have to call the DQ. So DQ means deleting an item from that queue. So you have to pass front, rear pointer and queue of item is 3. So you have to insert it, that is NQ in the first item is 3. So 3 will be deleted from that queue. So afterwards the last element and the before element will be shifted by 1 in that queue. Okay, so the second DQ operations, front, rear and Q pointer will be passed into that queue. So 5 will be in that queue in the first inserted item. So the first inserted item 5 is deleted from that queue. So the remaining element shifted to the first element. So next DQ operations will be called front, rear and Q. Item will be passed in that queue. The first element in that queue is 8. So 8 will be deleted from, the 7 will be placed into that first place. Okay, so now the DQ operation is called, the one more element in that queue is 7 will be deleted from that queue. Now the queue is empty. Suppose you have to call the DQ operations in that now So it will be reports Q is empty. So we cannot any items deleted from that Q. So that friends, NQ and DQ operation is used for inserting and deleting items in that Q and from that Q. Okay friends. So Q is empty and Q is full is the maximum capacity of the Q size it will be reaching or not. So watching this video, it will be used for helpful for the stack and queue operations for the basic steps. Thank you friends.